Yeah, good evening, students. In 9th standard science, today we are going to start a new lesson in physics part fluids. Yes, fluids means that kind of things as are in liquid state. Okay, liquid states materials are called as fluids. Okay, yeah. The what is fluids? Just I want to give some introduction part related that fluids. Yeah, a small nail is sink in water. Okay, the small nail is sink in water. Yes, this concept is we know about that. Yes, each and every material is sink in water. The nail sink in water, and that opposite of nail, that is huge ship of heavy mass float on a sea. Huge ship float on the sea water. Sis, compared to these two activities, one is a nail sink in water, another one is huge ship of heavy masses floats on sea water. Okay, so this is the very big differ, and then as well as the one of the such amazing fact also. Why these two concept is an opposite? Because of pressure. Yes, basic concept is pressure. Due to the pressure, the nail is sink in water, the huge ship float on the sea water. Okay. So the common reason is pressure. So if the pressure is increases in solid based on this inherent properties, the tension, and then ultimately the deforms of brakes. So in such a case, the fluids are ship, the huge weight ship is float on the sea and nail is sink on the water. Okay, sink in the water. So in this lesson, we are going to learn such topics like thirst and pressure due to the liquids. What are the properties factors determining liquid pressure in liquid pressure in liquids, and then buoyancy. So in these topics, we are going to learn this session. First topic is thirst and pressure. Yes, just we know about the pressure concept. Because of pressure, the small size of nail is sink in water. The large size of ship float on the sea. So, what is the thirst and pressure? These two concepts is related to the fluid lesson. What is thirst and then what is pressure? Thirst. First one, thirst is nothing but the force acting perpendicular to the force. That is called thirst. Okay. Force acting. First, I am explain the topic. Okay. Force acting perpendicular to the force. That is called as thirst. So the concept of thirst, force acting perpendicular to the surface, sorry. To the surface is called thirst, okay. Just we, one small, very small experiment, that is, we are taking one head pin, okay. The small size of pin, we want to pin the board. We want to pin into the wooden board in that head part. Is it possible? We want the pin into the board with the help of the head part. Is it possible? No, because the bottom part only sharp in this head pin. Yes, we want to pin the bottom part into the board. So this action is very easy. This is possible. Sit. Pushing a pin to the board by the head is difficult. Pushing by the pointed end is easy because this end point is very sharp. So that's why it is very easy. Why the truck on that motor bus? That tire is wider. Different kinds of vehicles we know. Heavy vehicle, that is truck, lorry, like that. That tire of that truck is very wide in condition. Why it is in wider? Why the tools are very sharp edges? That is a nail and then knife. Each and every iron particles, iron materials are, and that end point is very sharp, like that knife and then nail, like that. So in this situation, we can understand that phenomena. We need to learn about the two interrelated physical concept, that is thirst and pressure. In this case, that the pin experiment, so the force exerted on the sand and that weight of your body, which are the same. Okay, so that concept on you. Have you wondered that a camel can run in a desert easily? Why it is easy? Camel can run in that desert, but we can't. Why? Because that the head of the pin is not a point into easy, but that end point is easy to pushing that board. It is easy. In these two cases, those activity, the forces exerted on the sand, the weight of your body, which are the same, but the forces act as perpendicular to the surface. So that is called thrust. When you stand on a loose sand, the force is acting on an area equal to the area of your feet. Okay, just you concentrate that point. When you stand on a loose sand, the force is acting on an area equal to the area of your feet. Okay. So, in this concept, when you lie down, the same force acting on the area of your whole body. So, this is larger area of your feet. So, though this effect that depends on the area on which acts. So, the force per unit area acting on the object is concerned. That is called as pressure. Okay. Thrust means a force acting and perpendicular to the surface of the thrust, but pressure. What is the concept of pressure? Means the force per unit area acting on an object concerned is called pressure. So the concept of pressure is force per unit area acting on an object concerned is called as pressure. So in this way, we can say the thrust on an unit area is pressure. So thrust on an unit area is called as pressure. So what is the difference between the pressure and the thrust? Thrust is nothing but force acting perpendicular to that surface. But the force per unit area acting on the object concerned that same. So that is called that pressure. So pressure is equal to thrust divided area of contact. Pressure, formula of the pressure is thrust divided by area of contact. This is the formula of pressure. So, pressure equal to thrust divided area of contact. Because just I am going to explain the same concept. When you stand on the loose sand means the force acting on the area that is equal when you standing position, but lie down position, the same force acting on the area of your whole body, that is larger area of your feet, because 6 feet or 5 feet, it is differ each and every one. So therefore the effect of the thrust depends on the area which enacts. Okay, is that clear? So the same force, the area is larger, pressure is low, and vice versa. The area is large, pressure is low, and then vice versa. This is the pressure depends on the area of application. When you apply the lower pressure means, see this picture. See size of the stand, that is feet. This just you imagine, this is your feet, this is your body. Okay, when you apply the lower pressure in this area, here higher pressure in this area. So lower pressure means how it is. This is lower pressure. When we supply lower pressure here, when we supply the high pressure in this place. So the pressure is depends on the area of the application. Which one is larger? Yes, the bottom of the area is large here. Bottom of the part is very small in this area also. Just compared to the vessel, the bottom part is very small. Okay, so pressure depends on the area of application. So in this picture, explain that concept. Okay, so the SI unit of thrust is Newton. So thrust, we want to mention that unit because the unit of the thrust is Newton. Symbol is N. So thrust symbol is N. The unit of pressure is the Newton per square, that is Newton meter minus 2. N meter minus 2. Okay. So Nm, sorry, minus 2. And then Pascal, 1 Newton per square meter is called as 1 Pascal. That is 1 PA equal to 1 Newton meter per minus 2. 1 Pascal equal to 1 Newton meter per minus 2. So this is the unit. Okay. So what is thrust and pressure? What is the example? What are the explanation? And what is the formula of pressure? How the pressure is acting that different kinds of area. That is pressure depends on the area. So next concept is pressure in fluids. So already I explained all the flowing substance are called as fluids. All the flowing substances, that is floating substances. Pressure in fluids. All the flowing substances. Flowing means moving substances. Example, different kinds of oil, water, kerosene, petrol, diesel. These are all that fluids, all the flowing substances, both liquids and gases. Both gas and liquids. These two are flowing substances. Okay, liquids and gases. So, like solids, fluids also have weight and therefore exert pressure. When fill the container, the pressure of the fluid is exerted in all the directions. See, look at the picture. Yes, force due to the pressure in a liquid, pressure in a fluid. When we press that materials, all the sides are move. So the pressure of the fluid is exerted all directions at all the points on the fluid. Okay, so the molecules of the fluid are in constant and rapid motion because when we press the material into the liquid, so the particles are likely move equally in any direction. See the direction, in all the direction, the particles are move from that area. So the pressure exerted by the fluid acts in all directions. So this picture explains the force due to the pressure of the liquid. When we press the material to the liquid means, so the liquid particles are moved into all that area because of the pressure. So the molecules are raised on the pressure. For example, just you are taking one container filled with water. Okay, and this I want to put a small pieces of stone like that. So one or two stones I want to put into inside in that container means what will happen? Yes, the water will rise in that container because of the pressure. So the pressure in fluids. So just we put the solid material or the liquid material to the fluid means automatically the due to the pressure the fluids, the liquid is increase in that height. So just first the concept, flowing substances are called as fluids like liquids and gases. So the weight of that solids and fluids are have weight, therefore they exert the pressure. Yes, the each and every solid material have some weight. Because of the weight and pressure, the fluids are increased and moved in all the directions. Okay, so the pressure of the fluid is exerted in all directions in that fluid. So the molecules of fluid are in constant and rapid motion also. Okay, so second, so first one we know about the pressure exerted by the liquids, and then about the pressure exerted by the gases also, gas pressure. When we filled in a gas, for example, that LPG. LPG means that is liquid petroleum gas. When we open the knob means automatically it will be changed into that gaseous. So when we fill the gases in that container means the gas molecules are stored in this area. So the gas pressure is exerted from that container. Okay. So the gas pressure is come out. So gas molecules are arranged in that container. Okay. So both liquids and gases are have that examples for the fluids. So what are the examples for the fluids means liquids and the gases, both materials are called as that fluids. Solids and fluids also have weight, so therefore that pressure was exerted in that. Next one, pressure due to liquids. So the force is exerted due to the pressure, so the body are submerged. The stone is submerged. Submerged means it is merged. So that is called as submerged party, submerged. So for example, air-filled balloon is immersed inside the water. That is the best example for the pressure due to liquids. The next concept is pressure due to liquids. Force is exerted. Okay, so in that submerged point on the walls of the container is always perpendicular to the surface, that is thrust. Okay, so when an air filled balloon is immersed inside the water container, first we fill the water container and air filled balloon. Yes, the balloon is filled with air. I want to press the balloon into the water. What will happen? Yes, the filled balloon is immersed inside that vessel. The water is come out. Yes, comes up and then floats on the water. The balloon is come up as well as the water also come out that party, because the immersed inside the water vessel immediately comes up and floats. Just we want to immerse, suddenly it will come up. Okay, because the water exerts the pressure in the upward direction, so that the balloon was comes up. Okay, so this is the first example of the pressure due to the liquids. Because of the pressure, because the air is filled with air, so when we immerse the balloon into the sink, that is the vessel, means immediately it will comes up, because of that pressure is upward direction. That liquid pressure acts on that same side, in all sides. When a bottle having a water is placed on that solid, we can see that coming out with the speed of the water. Next example, I am taking one water bottle filled with water. The water bottle is filled with water. I want to put some holes in the bottom of the part of the bottle. Here, see, want to create 3 holes in that same places, same area in bottom part, that is that same places. So, this I want to open the holes, means what will happen? The water will come out that same force in all places, because the holes are in that same area. So there is no difference in that pressure. Okay, so the pressure acts on the lateral sides on that bottle. Though the bottle having that piece on the sides, we can see that the water is coming out with that speed. The speed of the water is same in all directions. So, because the liquid exerts the lateral pressure on the walls on the container. So, this concept is proved in the with the help of this example. So, liquid exerts lateral pressure. Liquid exerts lateral pressure. So this concept is proved this example. Okay. So on the walls of the container. So in this experiment explain that exert pressure in upward direction. Exert pressure in upward direction. So this concept is prove this example. So first we can fill the water in a vessel. Then I want to press one air-filled balloon to the immersed into the water. Immediately the balloon will come up that into the upward direction because exert pressure is in upward direction. So that the balloon will come up. Second example, I want to fill water in a water bottle. So, and just I want to create some holes in the bottom part of the bottle, want to open the holes on. So at the same time, the water will come down at the same speed in in all directions because liquid exerts lateral pressure on the walls on the container. On the walls on the container. So this concept is explained with this example. So these are all the examples for the pressure due to the liquids. Next one is factors determining liquid pressure in liquids. What are the factors determine the liquid pressures in liquid? So, factors determining liquid pressure in liquids. What are the factors determined? Yes, first one is depth. What is the first factor? Depth. So, that is height of the container. So, that is the point is depth. Second one is density of the liquid. This is also very important. Density of the liquid also determine the pressure because we are using different kinds of liquids compared to oil and water. So then density is vary to the oil and water. So density of the liquid also determine the pressure of the liquids. So this second one, acceleration due to the gravity. Acceleration due to the gravity. So this is the third concept determine the pressure in liquid. First one is height, that is depth, and density of the liquid, that is rho. Acceleration due to the gravity is g. So these three factors are determine the pressure in liquids. So first activity, going to explain the concept with the help of a simulation. Yes, with the help of the simulation, we are going to learn the concept. That is the fact. What are the factors to determine the pressure in the liquid? Okay, so we are taking three different sizes of bottles. So we want to give some name: bottle 1, bottle 2, and then bottle 3. Okay. So first we want to select the position of the hole in the bottle, top or middle or bottom. So I want to select in that same part. Okay. So I want to select the part here, top position of the hole in that first, second, three, or in that same part, that is top part. I want to close the holes of the bottle with the help of the sellotape. So this is different kinds of bottles. So I want to select the holes in that bottles in that same position in all the bottles. So I want to close the holes also. Then I fill the water in all the bottles. Yes, first bottle is over. Second bottle also over. And Third bottle, I want to fill the water. Yes, the water is filled in all the bottles. Okay, now I'm going to remove the sellotape in these bottles. Just you observe what will happen immediately. Okay. Students, already I explained, don't write, don't scribble, just you observe it, then you ask the question. So please look at this. The water is come out from the bottle in that same speed. There is no difference in their area. Okay. So here, when holes are at that same height from the bottom, the water stream falls at the same distance regards of the volume of the water on the container. So because the speed, the sizes or same, the holes at the same height in these three bottles. So the water stream falls at the same distance and then same speed also from that container. Okay. So because the holes are same part. So the from the bottom part. So next one. Yeah, students, is there any doubt? You type the question. Okay. Yes, you ask the questions. Just you type. Next one. I want to select the first bottle is in top position. Second bottle in that middle of that part. Third bottle, I am selecting bottom part. First bottle is top part. See, the blue color is in top position and then position of that second bottle is in that middle part and third bottle is bottom part. Okay. So I want to close the holes with the help of the sellotape. Yes, all the holes are closed in these three bottles. Next, we are going to fill the water in all the bottles. First bottle is filled. Second bottle also filled. And then, yes, third bottle also filled. So, the second way of the experiment, I am selecting the position of the holes vary in these three bottles. First bottle position is in top, second bottle position is in middle part, and third bottle position is in bottom part. Okay, so next I am filling the water in these bottles. Now I am going to remove the sellotape in these three bottles. Just to observe what will happen. What is going on? Yes, the distances differ. First bottle is 1 and then second is 2 centimeter. Third bottle is 3 centimeter difference. The speed and the distance is vary in these three because the stream of the water that emerges from the hole, that is farther away from the base, falls closer due to the lower liquid pressure. So the pressure, because of the pressure, so the bottom of the bottle means the pressure is high and then middle of the bottle holds the second bottle, the hole is in that center part, that is the middle part. So the pressure is compared to the third bottle is just lower. First bottle, the hole is in top part, so the pressure is very low. So the distance is very small. 1 centimeter, 2 centimeter, 3 centimeter because of the pressure. So what concept we can identify the depth? Okay. First, what are the factors determine the pressure in liquid means First concept, depth. So the depth concept is easily explained with the help of the simulation. I think you can understand the concept. Is it, students? What is the topic? Factors determining the liquid pressure in liquid. What are the factors? Depth, density, and third one is acceleration. So the pressure is varies and the depth is increased, but that same at a particular depth independent on the direction. So this concept is identified. Okay. So I think second concept is density. So how we can identify the density concept? So density. Density is very water and oil. Cooking oil or different kinds of oils. Okay. So first we are taking two kinds of liquids, that is water and oil. We are taking two container. One container I am going to filled water. So this container is filled in water. Second container filled with oil. I am filling the oil in the second container in that same level. Both are in the same level. Okay. So I want to create some holes in that container. So I want to create holes in this part. I want to open the container also. When we create the holes in the two same container and same part, what will happen? Yes, the water is firing with more pressure compared to the oil. So the water is come out fast. So the distance is high. Okay. And then next, the oil is come down slowly. The water is come out the container in very fast manner, but that oil is come out the container in slow manner because the density is higher compared to the water. So density is higher compared to the water because the oil is flowing slowly compared to water. Okay, so that water is quite with a more pressure than oil because the pressure depends upon the density of the liquid. Pressure depends upon the density. So this concept is prove this example with the help of this example. So second concept, density part. Density of the liquid also determine the liquid pressures. How it is possible means, yes, with the help of the example. First we are taking same size of two container. First container we want to fill with water and second container we want to fill with oil. Okay, in same level, and we want to create one hole in both container in same height. What will happen? The water will come out very fast compared to oil because the oil density is higher. So that the oil is come out very slowly. So that density concept is proved with the example. Okay. Next one, pressure due to a liquid column. So second, that is pressure. So first one is depth. And then second one is density. And then third one, that is the activity. First, pressure varies and the depth increases and the same at particular depth independent on the direction. Okay. So second one, density. Okay, density means can the water is squaring with the more pressure than oil. So it indicates that pressure depends upon the density of the liquid. Okay, that is third one is gravity. So the large plastic can that holds at the same line, vertical line, then the filled with the water. That example is already we see in the simulation. So third concept, that is pressure due to liquid on a column. Before that, I want to explain that topic is buoyancy. I think buoyancy is in your lesson topic. So next I'm going to explain the buoyancy concept. That is important part in your syllabus. Buoyancy. So first, what are the topics we learn in this lesson? First topic is thirst and pressure in liquids, pressure due to liquids, factors determining the liquid pressure in a liquid. Next topic is buoyancy. What is buoyancy? Buoyancy means already we know that the pressure is more than the bottom and the less than the top of the liquid. So the concept is easily identified, easily understand the concept. Is it? The pressure is more in bottom and less top of the part. Yes, this concept is clear or not? Yes, that the pressure is more at the bottom and less than the top of the liquid. Top of the liquid or top of the part. Okay. So the pressure differences causes a force on object and pushes an upward. So that kind of force is called as buoyant force. When the balloon is immersed into the water means it will come out fast in that area, in that upward direction. So that kind of force is called as buoyant force. So the pressure difference the pressure is differ in that area. So the pressure differences causes a force. So this force is called as, so the force on the object and then pushes in upward directions. Okay. Force on the object and the object and pushes it upward. Upward direction. So this kind of force is called as buoyant force. Pressure is more in bottom and less in top of the part. That is first point. Second point, the pressure differences causes a force on the object, pushes on upward. So pushes it upward. Okay. So this kind of force is called as buoyant force. What is buoyant force? This is one important question. What is buoyant force means pressure differences cause and the force on the object pushes it upward. So this kind of force is called as buoyant force. And then that phenomena is called as buoyancy. So what is buoyancy means? This concept is buoyancy. Nothing but pressure. Depends upon the pressure. So the pressure is more at the bottom of the part. What are the containers? So the container, the bottom of the part is the pressure is higher and that top of the part that pressure is low. Okay. So the pressure differences causes a force, the object pushes upward direction. So this kind of force is called as buoyant force. This concept is known as, that phenomena is called as buoyancy. Okay. See, look at the picture. What is buoyancy? See, this object. So the force, the object is come out from that weight on the object. So buoyancy concept is explain this picture. So buoyant object are with relatively high volume and then low density. So the object is in high value and low density. The object weighs less than the amount of the water is displaced, that the buoyant force will be more. So it will be floating condition. So this is called as, that kind of the object is known as positively buoyant. Positively buoyant object. Object weighs more than amount of the water. Object weight is more than the amount of water displaced means that kind of object is known as negatively buoyant. In buoyancy, there are two kinds of buoyant object. One is positively buoyant and another one is negatively buoyant, because that first concept, that is buoyant force will be more and will be float. So this kind of object is called as positively buoyant. Second one is object weighs more than amount the water displaced. How much amount of water is displaced more compared to the object? That kind of object is called as negatively buoyant object. So buoyant force. First one, want to immerse the material to the water. So this is wooden material. So immediately the wooden material was comes upward directions. Okay. So why it was come out? Because of the buoyant force. Buoyant force. Okay. The buoyant force acting on this area. So this buoyancy concept is done this place. Okay. Students, please don't write here. Please type your doubts. Okay. So what is buoyancy? The pressure is more in the bottom, less in the top of the part. The pressure difference causes a force and the object pushes it upward. So this kind of force is called as buoyant force. That phenomena is buoyancy. So there are two kinds of buoyant object. One is positively buoyant. One is positively buoyant object. What is positive buoyant? Positive buoyant is nothing but that we want to press the object into the water. The object weighs is less than the amount of water. Object weighs less than the amount of water. So this kind of material is called as, this kind of object is called as positively buoyant. So the amount water is, it has displaced. Such kind of object is called as positively buoyant. So the buoyant force will be more and it will be 4. Buoyant force will be more. Okay. So it will float. So this kind of material is called as positively buoyant. Object weighs less than the amount of water it has displaced the buoyant force. So will be more, it will be float. Okay. So the buoyant force will be more and it will float. So this kind of object, such kind of object is called as positively buoyant. Buoyant is divided into two types. One is positively buoyant, another one is negative buoyance. So next one is negative. Negatively buoyant object. What is negatively buoyant object? Negatively buoyant object concept is object weighs more than the amount of water. More than the amount of water. The object weighs more than the amount of water it has displaced. So this kind of object displaced, so the density is more. The buoyant forces less the object. So such kind of object is called as negatively buoyant. So less than the object, it will sink. So this kind of object is called as negatively buoyant. Object weighs more than the amount of water it has displaced. The buoyant force it less than the object, so it will sink. So this kind of object is called as negatively buoyant. What is buoyancy? What is buoyant force? What are the two types of buoyant? Okay, first one, buoyancy means that buoyant force means the pressure is more than the bottom and less than the top of the liquids. So the pressure difference, the force on the object will push the object into upward. So that kind of force is called as buoyant force. That concept is called as buoyancy. There are two kinds of buoyant. One is positive, another one is negative. Because positive buoyant means nothing, the object weighs less than the amount. Object weighs more than the amount, sorry. So that is called as negative. Less means that is positive buoyant. Okay, so object is divided into two. One is positive, another one is negative. Salt water provides more buoyant force in fresh water. This is one important question, important detail. Salt water provides more buoyant force than the fresh water because buoyant forces depends as much the density of the fluid on the volume is displaced. So salt water is more buoyant force. So this concept please noted in your notebook. Salt water contains more buoyant force because depends on the density of the fluids on the volume displaced. Okay. So next concept is Archimedes principle. Yes, this is also one of the important concept. Yes, Archimedes principle. Archimedes principle is consequent the Pascal's law. Archimedes principle is related to the Pascal's law. So, Archimedes devised the principle in the hydrostatic balance. So, there are two different types of containers filled with water. We want to immerse the weights into the water. Just immerse. What is the concept means? What are the concept noticed with the help of the experiment? Body is partially or completely immersed in the fluid at rest. So the upthrust which equal to the weight of the fluid displaced by it. We want to immerse the material means the equal weight of water will come out from that area. So that kind of principle is known as Archimedes principle. So that concept is nothing. The Archimedes principle means The body immersed in a fluid, vertical and upward, the buoyant force equal to the weight of the fluid is displaces. The water is displaced from that area. How much amount of water? The same weight of the water. When we immerse the 5 kg material means the same weight of water will come out that area. When we want to immerse only 2 kg or 1 kg material means that same kind of water is come out from that place. So this phenomena is known as Archimedes. The scientist's name is Archimedes. So the principle is called as Archimedes principle. When a body is partially or completely immersed in that rest condition, the upthrust force, that is due to the buoyant force, the water is come out from that area. Automatically the amount of water will also remove that place. So this concept, the equal to the weight of the fluid displaced by it due to the upthrust acting buoyant force. So the apparently losses part of the weight and apparent loss of weight is equal to the upthrust. So this concept is called as that Archimedes principle. So the body either partially or completely immersed. Okay. Understand the concept? Just we are taking two container or that single container. First, we immersed some different kinds of weights. In first container, I immersed in 5 kg. Second container in 2 kg weight means the same weight of water also displaced or come out from that place. So this concept is known as Archimedes principle. Okay. So the upthrust is equal to weight of the fluid displaced, apparent loss of weight of the body. Okay. Next one is Archimedes principle. Archimedes principle is, yes, Archimedes principle means the upthrust. Yeah, the upthrust forces act on that area. Weight of the liquid is displaced. Weight of the fluid is displaced. Weight of the fluid or liquid. Weight of the liquid is displaced. Apparent loss of weight of the body. Apparent loss of weight of the body. So this concept is as Archimedes principle. So apparent weight of an object is true weight of the object and then minus upthrust, that is weight of water is displaced. Apparent weight means that is true weight of the object, much amount of weight you immersed in air. So minus upthrust, that is weight of the water displaced. So this concept is the Archimedes principle. Okay. So students, you please ask what are the doubts, which concept is not clear. I want, please you inform or just you type the doubts. Okay. Don't scribble. First raise your hand and then type the doubts. What are the topics we learned in this session in the lesson of fluid? First concept is thrust and pressure. Yes, students, is there any doubt in this concept? Thrust and pressure. First, I explained the concept of thrust and pressure and the formula of pressure also. Is there any doubt in this area? Just raise your hand and type the doubts, or you can't understand the concept. Don't bother. I will explain once again. Second concept is pressure in fluids. This concept is clear. Is there any doubt in this area? What is the pressure? What is the pressure of the fluid? Fluid pressure, total force exerted by the fluid divided the area over which the force is exerted. That is the formula of the fluid pressure. This concept is clear, ma? Flowing substances. Second one is pressure due to liquids. That is the third concept. The third concept also understand, ma? First one I explained the thirst and pressure. Second concept pressure and fluid. Third concept pressure due to liquids. And then fourth topic is factors determines. Factors determine liquid pressure. Factors determine the liquid pressure. This is the fourth topic of this lesson. Is there any doubts in this 4 chapters? That is 4 topics. Yes. Fifth topic is buoyancy. Is there any doubt in buoyancy topic? Buoyancy topic is clear, ma? Final one is Archimedes principle. So, today's session, we learned the 6 topics: thirst and pressure, pressure in liquids, pressure due to liquids, factor determine the liquid, buoyancy, and Archimedes principle. So, is there any doubt in this area? You please ask me, or otherwise, just you go through all the topics today evening. Is there any doubt will comes, you please ask me in the next session. Definitely, I will explain your doubts and that clarification. Okay. Thank you, students. Jai Bharat, Jai Hind, Jai Vidya Shakti.